Welcome to the OCR Computer Science class. And today we are going to start with the component 2 of our OCR syllabus, UK based. And the topic name is algorithm, right?
Yeah.
Okay. So first question is, what is algorithm? Any
Is it's a way of thinking, not a way of thinking, a way of organizing ideas.
algorithms are the steps,
Oh, yeah.
right? You create a program, a specific task, we can say, to create a specific task or program, right? So algorithms are the steps to create a specific task or a program, or algorithms are the recipe of the program, right? Recipe means the way we create a program is called algorithm, right? Or you can say the steps of program is called algorithm. A very, very easy example, like create a cup of coffee. So if we are going to create a cup of coffee, so we need to follow the steps,
Yeah.
right? Like boiling the water, mixing the coffee mixture, boil it further, then add milk, sugar, and your mug is ready, isn't it?
Yeah.
So by performing these steps, we can make a mug of a coffee. And if I say that first I'm going to input the milk, then I'm going to input the mixture, then I'm going to input the sugar. So you said, no, 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 sir, these are not the steps. You are mixing the steps. So algorithms are always in a proper sequence. So that following sequence are going to make any solution, right? So once we are going to start the algorithms, there are two things to remind, that we need to follow the steps in a sequence, and we must look for the output. Like we know what will be our output, right? If we
Yeah.
keep these things in our mind, so it will be very easy to understand the problem. So for algorithms, we need something, and that thing is called computational thinking. So what is computational thinking? It is a way of understanding complex problems, like writing a program. So in order to form a solution that can be implemented by either a computer, a human, or a combination of both. So once we are going to understand the problem, means let's suppose I'm giving you the task to write an algorithm to print a sum of two numbers. So the first thing you need to understand, that sum of two numbers means you need to input two numbers, and then you are going to find out the sum, isn't it? So this thinking, like sum of two numbers means you need to input first number, you input second number, then you need to add them, right? So this thinking or understanding is called a computational thinking. Did you get it?
Yes.
Right. Okay. So there are three key elements to computational thinking. Like, what are the three main things? First, the decomposition means breaking a problem into the smaller pieces. Like if you have a big program to create or to do, so you need to break your program into the pieces, right? Why? Why did you do this like this? You're just breaking down the programs into the pieces. like this. Isn't it? Are you getting it?
Yeah.
So this thing is called decomposition. Like I break my program into 3 steps: input, process, and output. Isn't it? Input, process, and output.
Output.
So how many steps I'm going to do? 3 steps.
Input.
3 steps. So I'm breaking my program into how many steps?
3.
What are these?
Input, process, output.
Output. So it means that I just decompose my program into 3 steps. So I have a very less space there, so I write output. You understand it? Output.
Yeah.
Okay. So breaking down a problem into a small pieces is called output. Sorry,
Output.
composition. Got it?
Yes.
Second step of computational thinking is abstraction, removing details that are not relevant. Removing details that are not
Relevant.
How did you understand this thing? Any idea?
Would you break a problem down into
Yeah.
pieces
No,
and
no,
then
no.
take out stuff
That,
that's
that, that
important?
is that is a decomposition. But I'm talking about the uh I'm talking about the abstraction. So I'm just giving you an idea. Just a second. So I'm teaching you about the problem like abstraction, right? So I just wanted to clear you the thing that decomposition is right here. Chapter 7. Okay, there you go, abstraction. You have 2 different types of maps right here on your screen. Are you able to see?
Yes.
Which one of you can easily understand? The right hand
The
or the left hand side?
right hand side.
Yes, this is called abstraction. Like to to understand the things more clearly by removing unnecessary things. Like on the left hand side, you can see the roadmap with green color, with the yellow color, with the dots. I don't know what are these things, but it is very confusing for the readers. But on the right hand side, you can see the map, the road map is very clear. Here, I'm talking on the right hand side. So this map is a bit clear. So this map is just an easy way to understand the thing as compared to the left hand side map. So I remove the unnecessary things from the left hand side and I just draw the right hand side map in order to understand it more clearly. So this is called abstraction. What it called?
Abstraction.
Abstraction. So did you get it? Abstraction, removing details that are not relevant. Any confusion?
No.
Okay, now the next thing is algorithm thinking. So algorithm thinking, identifying logical steps from a problem to a solution to produce a reusable algorithm. So it's a very, very difficult definition, but I give you a very easy definition. Algorithms are the steps to create or perform a specific task, right?
Yeah.
So please write it down in your notebook and draw the program decomposition chart as well on the right hand side. I'm waiting. You have 3 minutes. So if you go through this, it will be more easy for you. Okay, so this is the same thing I have shown to you, that there is a map on the left hand side and the right hand side, and you can see which one is easier. So tube map abstraction, you can see tube. What does it mean? Tube map. You can see in this map, you can see these are the tubes. Look, the tubes, the tunnels. And right here, it is a realistic distances and locations. right? So you have two images. So in a tube map abstraction, you can see the things are a bit organized because they are following a straight tube lines. Look like this. So it is a different thing. Right here on our right hand side, it is a different thing. So this is how the abstraction works. It is going to, convert the real paths into a kind of tube map. This is a real path on the right hand side. Okay, now we can see some more satellite images here. You can see on the left hand side, the satellite image shows every tree, building, as well as roads, although the roads are not always very clear. So in this left hand side, you can see the ground, the green color here, the trees are here, the roads, the cars, and I don't know what is that thing. But right here, you can see on the right hand side, the map, whose purpose is to have people drive or walk around an area. So leaves out details about each and every building and tree in order to focus on the most important information, namely the roads and major buildings. So what do you think? Which one is easy?
The
Right-hand side map, of course,
one with the words. Yeah.
right? Because according to our use, the maps are only used for the directions, not for the trees, the grounds, the houses. Look here, it's kind of any trademark or something here. So we don't need these things. So abstraction covers up the things which is straightforward and easy. I think it's more clear now.
Yeah.
So these all things are the same which we have discussed. So I'm not going to, wasting my time. Okay, icons in WIMP are abstractions. Yes. In your laptop, you are using Windows or Mac. What operating system are you using?
Mac.
Mac. Okay, on a Mac, on your desktop, you can see the small icon. That icons are working as abstraction for us. Like they are going to just give us a straight shortcut for our applications. So there's no need to go into the map apps, search your map, sorry, not map, search your app, and you're going to waste your time in searching. So once you're going to use any application, you can just click on the desktop icons, right? So that icons represents the programs and files, the UI, user interface. So the actual programs and files are binary data stored as electrical or magnetic charges on a secondary store. Like every file in your computer is stored where? It's stored in hard drive, isn't it? Or SSD. So from hard drive, the computer are going to represent them in a form of icons, right? Icons on a desktop. So if you wish to open that file or program, what you do? You definitely click on the icons, isn't it? Look,
Yeah.
instead of going into the hard drive, searching for the file, did you do this?
No, you just
No,
click on it.
that's it. So icons are also the abstraction. So what is WIMP? Do you know about WIMP?
No, I've never heard that before.
Oh man, WIMP stands for Windows, Icons, Menu, Pointers. WIMP stands for Windows, like Windows. I'm talking about Windows 10, Windows 11. So in Windows, we have icons, we have menu, and we have pointers. Pointers means mouse pointers. Like we click with the help of a mouse pointer. Menus are the start menu. Did you see the Windows interface? I think you know that. The Windows interface have a very beautiful desktops, icons. There's a menu in the start bar. You click on that menu to shut down your computer, isn't it? Like Mac.
Yeah.
Like Mac have a menu bar on the top, but Windows have a menu bar in the bottom, isn't it?
Yeah.
So these things are called the WIMP, Windows Icons Menu and Pointers. So these all things are working as abstraction. to do the shortcut. So whenever you wanted to execute any program, what you do? Can you tell me? You need to double click on an icon to open. So it will give a command to the operating system to load that binary data into memory. So you know that our computer stores data in a form of
Um,
binary. So
fine.
when
Okay.
we click on any icon, that icon sends a signal, a command to the memory to load that program, which is stored in a form of binary in our memory. Is that clear?
Yes.
And if you wanted to drag and drop icon, so it is also a very good thing. So we can just drag the icon, drop the icon from one folder to another. So it is also done in a shortcut way. So abstraction means to do the things in a lesser time without any complication. Is that clear?
Yes.
Please write down the full form of Windows icons WIMP, and you need to write down 3 points. Quick. Back. Okay, now other examples of abstraction. Okay, now we are going to understand that abstraction means to remove unnecessary material from our program. Am I right?
Yeah.
Abstraction means, come on, to remove,
Unnecessary program.
yes,
Unnecessary
unnecessary text.
information.
Information, yes, you can use information word as well. So now let's integrate our topic with the programming. Like in a computer programming, what is in there? Variables in programs are used to represent real entities, such as the names of a player or their score. Now, variables. What are variables? The question arises. Like, did you play games?
Yeah. Yeah.
Okay. In a game, once you are going to choose any player, the computer is asking to enter your name, and you enter your name as Adam. So
Yes.
the character playing in the game is a character, but what is the name of that character? Adam, isn't it?
Yeah.
Okay. Now I'm going to play the same game. Now the computer is asking me to enter your name. I input Minhaj. Now what is the name of that character? My name, Minhaj,
Yes.
isn't
Yeah.
it? My name. So once you are playing the character, you're playing with your name. Once I'm going to play that game with the character, I'm going to input my name. It means that names are changing. Names are
Changing.
changing. So the value which is changes is called variable.
Yeah.
Like in a game, you can input any name to that character. So it means it is variable. Okay, now Adam. Adam's age is 15.
Yeah.
Adam ages 15. And if any other student come, let's suppose John. John ages 16. So age is also changing in a program. Like every student is going to input their own age, but the variable in which they are going to input the value is a age. So age is also variable. So variables are the boxes. Look, they are the boxes. They're like a boxes in which we are going to input our name or our age. So the names and the age are changing according to the student. So that variable, look, this is a variable boxes. So in that boxes, we are going to input our data, age and name. So the names are changing, the ages are changing, and that changeable values are called variables.
Yeah.
That changing values are called
Variables.
variable. Is that clear or not clear?
It's clear.
Right? What are variables?
Changeable inputs.
Come on, yes, yes, yes. The things which are changeable is called
Variables.
variable. So it means in the program, if I'm going to input the values, let me explain you one more thing. Just a second. I got my document. So, okay, are you able to see that document on a Word?
Yes.
Okay, in this example, what you're saying that there are variables as, look, they are the variables and they are in a form of,
Letters.
yes, look here. Just look here. Okay, just a second. Okay, look, this is a player name. What is the name of the player here? Jumpman. And what is the high score of that player? This is the high
5.
score. This is the
Yeah.
high score. So if you're playing this same game, so you put your name Adam, and you're going to enter your own score, whatever the score is. So it means a player name or the high scores are, come on, variables.
Yeah.
So, so in a computer program, if you're going to input your name, look here, your name, you input Adam, you input your own age, you input your own address. So these all things are called variables. So what are variables? Variables are the data values that can change when the user is asked a question. For example, their age. So variable may change during the program execution. Any problem?
No.
Please write down this document word. Variable definition and this high score example, and most importantly, you need to write down this. Name, age, address. These all things are variables. Quick. Read the line. So a piece in a board game might be represented a computerized version of the game as a grid coordinate, whilst the board itself might be represented as a 2D array. What is array? Do you know?
Is it repeating
Look,
list?
this is a board. In that board, you have some boxes like this. Look, these are the boxes. So it is called grade as well, isn't it? Grade. So every box have an specific location. Look, like this is a row 1, this is row 2, this is row 3, this is row 4, right? Now,
Yeah.
this is column 1, this is column 2, this is column 3, this is column 4, this is column 5. Now, can you tell me the position right here? This one.
Uh, 3, 4 or 4, 3.
Yes, 3 comma 4. That's perfect. This location means it is an array. Location, a specific position. So once you are going to, in programming, abstraction is also a kind of a, finding a location of a thing. So that particular location is found with the help of an array. But what is 2D array? 2D array means that you have a one row and a column. So 2 dimensions, row, column, 2 dimensions. Look, right here, I'm going to draw an axis for you. Look. So now did you understand? 2 columns, 2D array. One is for X axis and one is for Y axis. So Y lies on C. Look. No, Y lies on rows. And X lies for the column, I think. No, you can use X for this axis and Y for this axis. Yes. So Y is for column, you can see. So in this way, you're going to take 2 dimensions. So 2D array means 2-dimensional array. In 2-dimensional array, what you got? Row and the column. So it is also called abstraction in the programming, right?
Yeah.
Okay. Okay. So I'm moving to the next document. Right. Decomposition. Oh my God. They link the decomposition with the living organisms. They're decomposing. But in our computer science, like decomposition means breaking down a complex program into a smaller manageable parts. So each part can be then solved individually. So I give you an idea that in decomposition, you are going to make a flowchart or a structured diagram like this. Like this. So I break my problem into how many steps? Tell me. 3 steps.
3.
Okay, further I'm going to break my problem like this. So I can do this. I can do this. Further dropping my problem into more steps. So this thing is called decomposition, right?
Yeah.
Any problem?
No.
Okay. So what is decomposition?
When you break more complex problems into smaller, more understandable problems and solve them individually.
Perfect, perfect, perfect. So we have done it already, so I'm not going to make you write the things again. Okay, look here, there's a chart. So I have drawn the same chart here. So you can see this chart. Look, this is a problem. We sort out the problem into the steps. But what are these steps called? These steps are
Sub-problems.
called, yes, yes, yes. What?
Sub-problems.
Yes, perfect. Subproblems. And what about these steps are called? Again,
They're
subproblems.
also sub-problems, yeah.
Yes. So this type of chart is also called a structure chart, right? So this chart is known as a structure chart, are used to break a large problem into the smaller parts, right?
Yeah.
Okay, write down the structure chart definition and draw a rough structure chart. Wait.